So today we're gonna go over chapter 4 topics. Uh, uh, it's really important part of Java, classes and objects. So class. So think of a class as a blueprint. It's like the plan for building a house. You can't live in the blueprint, but you can build houses from it. So each object you make from that class is an actual house you can walk into. So in programming, the class describes uh, what data something has and what actions it can do. So the data are called fields, uh, and the actions are called methods. So for example, let's say we have a simple student class, and a student might have fields like name, GPA, and the class can also provide methods like get name, to read the student's name, or set GPA to update their GPA. So when you create a student object, you're making one specific student with those fields filled in. So let's say uh, we could say like student Alex is equal to new student, gives us an actual student object, not just the blueprint. So something to remember here is, some people think a class is just a folder of code, or just another variable. It's more than that. It's the design. The object is the real thing you use in your program. So also don't confuse things with that belong to the whole class, like static members, with things that belong to each object. Next we have class. So how do we actually write one? Defining a class in Java actually always starts with the class keyword. uh, let's say public class student, and variables private string name, private double GPA, and then public string get name, return name. Let's close, and public void, let's say set GPA double new GPA, and GPA is equal to new GPA. So here we've got a simple definition. The fields like name.
So yeah, like you define new class or something.
This is not a new class. It's a regular class. Nothing new. It's a regular class. So we have here fields. Fields are basically name, GPA, which represents the student's state, and the methods we have set name, set GPA, which lets us safely access and change that data. And you'll notice that the keyword private on the fields, as that means code outside of the class can't directly poke at those variables. This is a good thing. It keeps the data safe. Instead, we can provide public methods, getter and setters, to interact with them. So don't make fields public for this kind of data. It feels easier to at first, but you lose control and can't protect your data. Also, watch your naming. Stick with camel case and meaningful names like student name, final grade, and don't forget to add default constructor if your class needs one. Otherwise, your code may not know how to build a new object. So
How is different like public and private? Does it matter?
it matters if you want to protect your
Why?
data.
Why does it matter?
So
For a simple programming or like?
no, like if you're building an application for a university,
Mhm.
and university students' data is very important, like ID, names. So at that particular instance, you need to protect your data,
Right.
and yeah, it depends on the program that you're working.
Project.
Yeah, project you're working. So yeah. And yeah, don't make fields public. It feels easier at first, but you lose control and can't protect your data. Also watch your naming. Stick with camel case and meaningful names. Yeah. So yeah, a class is a blueprint. An object is a real instance built from that blueprint. Fields are basically
Fields
data.
mean like variable or?
Yeah, variable data. These are your these fields are your data. Methods are your actions.
So how many classes in the Java?
How many classes? What do you mean?
Like
We can make as many classes that we need. There's no limit for classes. Yeah. Yeah. Keep fields private whenever required. Expose them with public methods. That's the foundation for object-oriented programming. Once you get this, you'll see how programs can grow in much more organized way.
I'm asking the blueprint. The blueprint they put it in the Java.
Mhm.
We use this blueprint as like build our programming stuff.
Mhm.
That's it. So the blueprint is not our hand. They already
So blueprint is basically just explains you the structure. Like this is where the class is, this is where the method is, this is where the fields like the variables are. But like as your program goes, or as you add more functions, that blueprint it's gonna be bigger and becomes bigger and bigger. But it's not like a default thing. The blueprint it depends on what you're doing with the program. Okay. So next we'll talk about two building blocks you'll use all semester, where your Java program starts, which is the main, and how to write your own methods. So every Java app needs a front door. The front door is the main method, which is basically public static void main string So this is the official program entry point. When you press run, the JVM Java Virtual Machine looks for a class that has exact method and starts there. So in plain English, public only the JVM can call it. We have static. It belongs to a class, not a specific object. That means Java can run it without creating an instance first. Void, it doesn't return a value. string args, which is a command line argument if you need them later. Few things to remember is putting main in class A but running to but trying to run class B. The runner only starts where main actually is. So having multiple main methods across files and running the wrong one, and forgetting static, and wondering why the IDE can't find a valid entry point. So things like that, keep in mind. So next we have user defined methods. So let's talk about methods you write yourself. A method is just a named chunk of work. You define it once, you can call it many times. A method's header has 4 main parts. We have access modifier, usually public for methods. You'll call for other classes. We have a return type void if it returns nothing, or type like int, double, string, and then name. Name is basically lower camel case, and it should describe what it does. Like, for example, if you're calculating score, calculate score, things like that. But yeah, then we have parameters. Parameters are basically inputs the method needs to do its job inside the parentheses. Two big principles here is one method is one job. So like if your method is doing 5 things, it's really 5 methods crammed together. And good names save time. So what to watch out for is if your method says it returns something like not void, you must return a value of that type. Don't declare parameters you don't use. If you don't need it, delete it. Avoid changing unrelated global state. So keep your method focused and predictable. Like if your IDE says no main method found, what's likely wrong is you either put main in a different class than the one you ran, or your main method signature isn't exactly public static void main string args. And if your method header says int compute score, but you forgot return, what happens? You'll get a compile error, because Java expects you to return an int from all paths. And if your method name is dolt, can you guess what it does next week? Probably not, because so rename it so future you understands it instantly. So yeah, put main in the class you actually run. Remember, static means it belongs to the class. Write a small clearly named methods, pass in the data they need as parameters, return a value when appropriate. Keep methods focused, one job, one place, so you'll debug faster, reuse more code. That's about the main and methods. Next is return. So we're gonna talk about something small but really important, the return statement in Java. So when you write a method, you have to decide, does this method do some work and return a value, or does it just act and not give anything back? So if your method returns something, you declare the return type in the method's header. For example, int, double, string. So whatever type you want to send back, then somewhere in the method you write a return statement that hands the value back to whoever called the method. So think of it ordering food at a restaurant. You place the order, the method calls, the chef makes your meal, and that's the method doing its work. But until the chef actually brings the plate out, that's the return. You don't have anything to eat. So now compare that to a void method. Void means it doesn't return anything. It still does something, maybe prints a message like updates a score or changes a character's health. But when it's done, it doesn't hand you back a value. So few things to watch out here is, if you say a method is supposed to return a type like int, then every path in that method has to end with return like some int. If you forget, the program won't even compile. And if you return wrong type, like trying to return a double from a method that promised to return an int, Java will stop you. And don't forget to use the return value. If you call a method that calculates damage in for example in Unity, it's a game dev software, so, and it hands you back a number, but you never assign it to anything. You just wanted the work. So so imagine you write a method, int get score, but inside the method you never write a return statement. What happens? The compiler compiles because you promised an int but never delivered. And another one is, if your method header says void, what does that mean? Exactly, it means the method performs an action but doesn't return anything to the caller. So some of the takeaways here is, methods either return a value or act without returning, which is void. The return type in the header must match the actual value you return. Always use returned values, otherwise the work is wasted. Yeah, that's it for return statements. It's a tiny piece of syntax, but it's at the core of writing clean, reusable methods. Once you get this down, your code will start looking much more organized and powerful. Next topic is defining methods. So we'll talk about why we even bother writing methods in the first place. So we've been using built-in ones like to uppercase. You have started writing your own, but let's break down why methods are such big deal. So first reason is reuse. So if you find yourself writing the same chunk of code more than once, that's a sign it belongs in a method. Instead of copy pasting, you define it once, then just call it whenever you need it. That saves time and keeps things consistent. Readability. So big blocks of code are hard to follow, but if you break things into smaller methods with clear names, your code reads almost like English. So that's one example. Testability. So smaller methods are easier to test. If you write a method that only calculates damage based on attack and defense, you can test it in isolation. You don't need to run the whole program to know if the math works. That makes debugging way less painful. And abstraction. So this just means hiding the details. You don't have to care about the step-by-step math inside, like math.square root. You just trust it. Your own methods should work the same way. The caller just says do this thing without worrying how it's done under the hood. So yeah, don't write monster methods that try to do everything at once. They're hard to read, hard to test, easy to break. and don't fall into copy paste coding. It feels fast in the moment, but later you have five versions of the same bug scattered around your code. uh, so methods exist to make your life easier. They lets you reuse work, make code more readable, test things in small pieces, and hide complexity. The goal is always the same: write smaller, cleaner, and smarter code, not longer code. Um, but when you work on your labs this week, you'll get a better understanding of what I'm talking. Next is unit testing. So we're going to talk about something sounds fancy, but it's really just a common sense. Unit testing. So what is unit testing? The idea is simple. Instead of running your whole program and hoping for the best, you test individual pieces, usually methods, in isolation. You give the method some known inputs and check whether the output matches what you expect. Like here's an example is, let's say you have a method called calculate damage that takes a attack value and defense value. If you call it 10 attack and 5 defense, maybe you expect the result to be 5. That's a test. You didn't have to load your entire run the whole code. You just checked this one little method. uh, so that's how unit testing works. So why it's useful is because small focused tests run fast, and they tell you right away if something is broken. If test fails, you know exactly where to look. The problem inside that method, not buried somewhere in an entire code base. So keep your tests small, quick. Don't overcomplicate them. Always test edge cases, not just a happy path. The happy path is the normal situation, like positive numbers or average input. But what if the attack is 0? What if that the damage is bigger than the attack? What if someone pass in a negative value? A good set of checks, tests check those two. So when naming your tests, make the purpose obvious. Something like test calculate damage with attack 0 tells you exactly what it's checking. uh, only testing the easy expected cases, and don't do this, like only testing the easy expected cases and ignoring the weird ones. Assume your method works without actually trying edge inputs. So if you wrote a method that calculates the average of a list of numbers, what would you test? You test a regular list like 10, 20, 30, but you'd also want to test 0, which is an empty list, or even negative numbers. That's how you make sure your method is solid. So unit testing isn't about being perfect. It's about being thorough. By writing small, meaningful tests, you can catch bugs early, and you can trust that your methods work the way you think they do. Uh, yeah, that's it for unit testing. As you go through the week's activities and labs, don't just run your whole program once. Call it good. Try testing your methods one at a time with different inputs. It saves you hours of frustration later. Uh, so the last topic for today is this keyword and documentation, class documentation. So we'll cover two things that makes everyday Java coding smoother: this keyword and how to read Java class documentation without getting lost. So first is this. Let's start with so in plain English, this means the current object. Whenever you're inside a class method and you say this, you're pointing at a specific instance that's running that code. Why is that useful? There are two big reasons for that. Uh, First one is disambiguate field and parameter names. So if a constructor or a setter uses parameter names that are the same as your fields, that makes it crystal clear which one you mean. Think like try the parameter value and store it into this object's fields. And next is call other instance methods or pass yourself around. So sometimes you want to say call another method on this object, or you need to hand the current object to another method. This is the handle for that. And where you'll definitely use it is constructors and setters. So if your class has a private string name and your constructor is student string name, then inside the constructor you will set this dot name is equal to name, and the left side is the field, the right side is the parameter. Let me write it down. Say student string name, then you write let's actually define it first. String name, let's put it as private, and then inside the constructor, this is your constructor, you'll say this dot name is equal to name, and the left side is basically the field and the right side is the parameter. Without this it's ambiguous, so don't use this in a static context. The static methods belong to the class, not an instance, so there's no current object there. Watch out for accidental shadowing, so reusing the same name for both field and parameter without realizing it. If in doubt, use like this dot field name, so it's obvious. If you ask what is this referred to inside a non-static method, the answer is the current object calling that method. Next let's talk about Java documentation, class documentation. So in documentation, Java standard library is huge. The docs are your map. The trick is knowing where to look and what to read. When you open docs for a class, say string, math, or array list, focus on focus on few key pieces, like method signature, the name, the parameter list. This tells you what input it needs. For example, substring int begin index, int end index. These are two integers. And return type, what you get back. That's we have parameters, parameter details and behavior notes, and exceptions, examples. Many docs include short examples. Grab them, they show the intended use. And don't skim and guess. Don't assume you remember the parameter order or whether something is inclusive, exclusive. Always check. And don't confuse similar methods. For example, substring, subsequence, or add versus set on the array list. The docs clarify the differences. What to look up often is string. You'll get substring, index of, replace, split in the string category. If you look for math, you'll have square root, minimum, maximum. If you're looking for array list, it will have add, set, get, size, remove. Where do you find where do you find whether substring includes the end index? In the official API documentation for string.substring, the method description spells out that the end index is exclusive. That's a quick example. So yeah, this points to the current object. Use it in constructors, setters when parameter names, shadow fields, and never use in static methods. Docs documentation are your friends. Read method signatures, return values, behavior notes, verify parameter order and inclusive exclusive rules. Check examples. Yeah, that's it for today.